Download this code from codegive.com, link in the description below. Backpropagation in neural networks, an informative tutorial. Backpropagation is a supervised learning algorithm used for training artificial neural networks. It is an efficient method for calculating the gradient of the loss function with respect to the weights of the network, allowing the network to update its weights to minimize the error. Key concepts of backpropagation. 1. Feed-forward pass. The input is passed through the network layer by layer, resulting in an output. The output is then compared to the expected output, and the loss is calculated. 2. Loss function. This function measures how well the network's predictions match the actual target values. Common loss functions include mean squared error, MSE, for regression tasks and cross-entropy loss for classification tasks. 3. Gradient descent, a method used to update the weights of the network. The weights are adjusted in the opposite direction of the gradient of the loss function, scaled by a learning rate. 4. Backpropagation algorithm. This is the process of computing the gradient of the loss function with respect to each weight by applying the chain rule of calculus. Steps in backpropagation. 1. Initialization. Start with random weights. 2. Feed-forward pass. Compute the output of the network. 3. Compute loss. Use the loss function to determine the error. 4. Backward pass. Compute the gradient of the loss with respect to the output. Propagate this gradient backward through the network to compute the gradient of the loss with respect to each weight. 5. Update weights. Adjust the weights using the gradients computed in the backward pass. Example code. Below is a simple implementation of a neural network with backpropagation using Python and NumPy. This example features a single hidden layer and is designed to solve a binary classification task. Explanation of the code. 1. Sigmoid function. The activation function used here is the sigmoid function, which outputs a value between 0 and 1. Its derivative is also defined for use in backpropagation. 2. Neural network class. The simple neural network class contains methods for initialization. Weights are initialized randomly. Feed-forward. Computes outputs from inputs. Backpropagation. Calculates gradients, updates weights. Training. Runs the feed-forward and backpropagation process for a specified number of epochs. 3. Example usage. The XOR problem is a classic example of a function that is not linearly separable, making it an interesting case for a neural network. The network is trained for 1000 epochs, and predictions are printed afterward. Conclusion. Backpropagation is a fundamental algorithm for training neural networks. Understanding how it works, along with the forward pass and weight updates, is crucial for anyone looking to delve into deep learning. This example provides a basic illustration of how backpropagation is implemented in a simple neural network. For more complex applications, consider using established libraries such as TensorFlow or PyTorch, which handle backpropagation and other aspects of training neural networks efficiently.